Suppose X, the amount of time in minutes a student uses a computer terminal at an on-campus lab, follows a gamma distribution with a mean of 20 minutes and a variance of 80 minutes squared. All right, so what are the values then for alpha and beta? Well, if mu of X is equal to 20 and sigma X squared is equal to 80, we know that the average of a gamma distribution, so the expectation, is equal to alpha times beta, and the variance of X is equal to alpha times beta squared. So basically we have two equations and two unknowns. So alpha times beta is equal to 20, and alpha times beta squared is equal to 80. So if we solve for alpha in this original problem, it says alpha is then equal to 20 over beta, and plug it in over here, then we get 20 over beta times beta squared is equal to 80, which is, of course, just then 20 times beta equal to 80, divide both sides by 20, and that means that beta is equal to 4. All right, and so then we can just take this beta and plug it back into this equation over here, and we get then alpha is equal to 20 over 4, which is equal to 5. So this means that alpha is equal to 5 and beta is equal to 4. So what then is the probability density function for X? Well, then f of X, because it's a gamma distribution, is going to be equal to, now I'm going to just do the general form first, beta to the alpha, gamma of alpha, times x to the alpha minus 1, e to the negative x divided by beta. So if we plug in our alpha and our beta for here, for these problems, then we get 1 over 4 to the 5th gamma of 5 times x to the 4th, so 5 minus 1 is 4, e to the negative x over 4. All right, so this is then our probability density function. And so if we want to find probabilities, then we can calculate them just like we've done with all the other general probabilities, basically by integrating from our lower bound up to, like, let's say in this case, if we wanted to find the probability that x is less than 10, then we'd integrate this function from 0 to 10. The issue is that it starts to get pretty nasty with this x to the 4th e to the negative x over 4. We have to do integration by parts several times, and so instead of doing this by hand, we're going to use software. So let's go ahead and move on over to R. And here in R, I've already then defined our alpha equal to 5 and our beta equal to 4. You don't have to do this, but I like to set up my problems this way so I can just then easily then pull up the commands. So I'm going to run these two lines so I can define alpha and beta. And as you can see, it comes down here in my console window. And then I'm going to run the line P gamma. So if I want to find the probability that the number of minutes is less than 10, then I can use this command. This is the cumulative distribution function, or cumulative density function for the gamma random variable, where 10 is my value of interest, alpha is my parameter, my shape parameter, and beta is going to be, 1 over beta will be my rate parameter. So I'm going to run this line, and I get that the probability that x is less than 10 is equal to 0.10882. That was a lot faster than trying to do this by hand. All right, so the next question asks, what is the median of x? So what is the median amount of time that a student is on a computer terminal at the campus lab? We can calculate that using the command q gamma, and we plug in the percentile that we're interested in. So if this is the median, that's 0.5. We have alpha again as the shape parameter and 1 over beta as the rate parameter. And if we run this line, we get 18.68364. So that is then the median of this distribution. So R really helped to cut down on some of the busy work, but we did need to know that we had a gamma distribution with an alpha equal to 5 and beta equal to 4.